Ever driven through the countryside and been like, huh, doesn't this seem kind of samey? Like,
Well,
where'd all the funky old barns and winding hedgerows disappear to?
it's something you notice, right?
Yeah. Turns out there's a whole science to figuring out how landscapes change and what it all means. And today, we're diving into how Norway's tackling this head-on.
Such a crucial topic. We get caught up in the big, dramatic environmental stuff, but these subtle shifts in our landscapes, they're happening everywhere, all the time.
Totally. It's like you miss the forest for the trees, or in this case, the changes to the forest because we're glued to our phones.
Sadly true.
Luckily, Norway's on it. They've got this crazy ambitious program tracking their farmland using aerial photography. We're digging into the research paper.
Glad we are. The title, and I quote, Development and Implementation of the Norwegian Monitoring Program for Agricultural Landscapes may not scream thriller,
Definitely not a beach read.
but trust me, it's fascinating once you dig in.
Oh, it totally is, like being a detective, but for the land itself.
Yeah.
But before we go full Sherlock, let's set the scene. The paper starts with a surprising fact. Only a tiny bit of Norway is actually farmable, like 2.7%.
Wild, right. And that tiny percentage isn't just about food. It's where most Norwegians live, work, connect with nature.
So it's not just some pristine wilderness we're talking about, it's the everyday landscape that's changing. And speaking of, the paper mentions this trend, not just Norway, but all over Europe, towards these like more uniform landscapes.
Homogenization, it's called. Might have noticed it yourself. Remember those rambling farm roads, all jumbled up with fields, meadows, a bit of forest?
Oh, totally. My grandparents' farm was like that, a patchwork quilt of different things.
Exactly. Now it's all huge, single crop fields everywhere the same.
Yeah, like, where's the variety?
And that's the problem. Those messy landscapes, they were ecological gold mines. All those habitats meant more plants, animals, made the whole system stronger.
Like a diverse stock portfolio, don't put all your eggs in one basket. But we're doing that with our landscapes.
Kind of, yeah. And that's where Norway's program comes in. They're trying to get ahead of it by tracking these changes systematically. Hence, their program, catchily titled 3Q.
Way better than its actual name, I gotta say.
Oh, for sure. Tilstands overvåking og resultatkontroll I jordbrukets kulturlandskap. Doesn't quite roll off the tongue.
Not one you'd remember easily. But 3Q, catchy, and it makes sense. What's the quality of our farmland? What are the quantifiable changes? And what do they mean long term?
Exactly. Early detection, right. Before it's too late to fix things.
A checkup, but for the land itself. So what are they actually looking at? I was surprised it's not just like counting trees. It's broader than that, right?
Way broader. They've got 4 key areas, super holistic. First up, the actual structure of a landscape.
Okay, structure. Paint me a picture.
Imagine looking down from above. Is it a patchwork of fields, forests, hedges, a winding stream, all mixed up? Or mostly these giant, identical fields, no variety? That's the structure.
So more variety. Good.
Usually, yeah. Means more habitats, more species, more resilient.
Got it. So that's one piece. What else?
Next, the obvious one, biodiversity. What's living there and how are they doing?
Makes sense. Got to know who's at the party. What's number 3? This one surprised me.
This one's cool. They're looking at cultural heritage. Might seem unrelated to the environment, but it's all connected.
Okay, now I'm intrigued. Break it down.
Think old buildings, traditional farming ways, even just the presence or absence of things like stone walls. It speaks to how humans have shaped the land over time.
So it's about understanding not just the ecology, but the history of the land.
Exactly. And that history tells us why it looks the way it does now and what we might need to protect for the future.
Okay, starting to see the connections here. We've got structure, biodiversity, cultural heritage. What's the 4th one?
The 4th area is accessibility. How easy is it to actually get around in these landscapes?
Accessibility. Like if the roads are any good.
Well, more like, are there paths, trails? Can people actually experience these spaces without trampling everything?
So it's about making sure people can enjoy the landscape without loving it to death.
Exactly. Sustainable tourism, recreation, all that good stuff.
So we've got these 4 pillars: structure, biodiversity, cultural heritage, accessibility. Ambitious. It's like they're trying to get inside the land's head.
Right. And that's what's so cool about it. You can't separate the ecological from the social, the historical, the recreational. It's all one big system.
So how do they actually do it?
Yeah.
Did they have scientists with magnifying glasses, like counting every blade of grass?
A little more high-tech than that. Think less magnifying glass, more high-resolution cameras on airplanes.
Spying on nature from above. Love it. But seriously, how do you capture a whole country like that? Seems impossible.
It's a massive undertaking, for sure. They've got this clever system. Imagine a giant checkerboard over Norway. Each square is 1 square kilometer.
Wait, they're photographing every square. That's intense.
Well, not every single one, remember, only a small part is farmland. They're strategically picking squares within those areas, a sampling method.
So it's like a representative snapshot.
Yeah.
Still, that's got to be a ton of data. What do they do with all those photos?
That's where the magic happens. They've got trained experts who analyze those photos, looking for specific features and changes related to those 4 areas we talked about. And the detail they get, it's mind-blowing.
Okay, now I'm imagining those super zoomed in satellite pics where you can see people's faces. How detailed are we talking?
Not quite Google Earth, but close. The paper mentions the resolution is incredible, down to 0.5 meters in some cases. They can see individual trees, fences, small buildings even.
Wow. But even with that, there's got to be room for error. Right. Like, is that a sheep or a weirdly shaped bush?
You'd be surprised. The paper actually talks about this. It can be tricky to tell certain things apart, even from the air. For example, different types of grassland.
Really? You'd think it'd be easy. It's just grass, right?
Right. Turns out there are tons of different grasslands, each with its own unique makeup. And those subtle differences, they're tough to spot from above.
The more you know. So if they're having trouble with the common stuff, what about the rare things?
That's the thing, right? It's like trying to find a needle in a haystack. The rarer something is, the harder it is to spot, let alone track its changes over time.
So what's the solution? How do you make sure you're not missing those crucial but elusive details?
That's where those field teams come in. Remember them. It's not enough to just look from above sometimes. You got to get your boots dirty.
So they've got all this incredible data about Norway's farmland. Like they're building a time lapse of the land itself changing right before their eyes. But data for data's sake is just, well, data. What are they actually doing with this goldmine of information?
That's the million-dollar question. They're not just taking pretty pictures from the sky, right? They want to use this info to make smarter decisions about how to manage those landscapes for, for the future.
So are we talking boots on the ground changes? Like, has this program actually influenced things? Things like, I don't know, agricultural policies, conservation efforts, even how towns are planned?
That's the big question, right? The paper says it's still early days for the program. We're thinking about long-term trends here, and those... well, they take time to really show themselves.
Makes sense, I guess.
Yeah.
Rome wasn't built in a day, right?
Yeah.
And neither is a sustainable farmland system, I guess.
Exactly. But here's the thing. Even if it's too early for them to completely change their policies, they have established a baseline. They have the super detailed picture of what their farmland looks like right now.
Which is important because...
because now they have something to compare to. In 5, 10, 20 years, they can take new aerial photos, right?
Yeah.
And compare them to this baseline data, like a before and after picture for their entire country.
So they'll be able to see, what's changed, which parts are doing well, which are struggling, and then they can connect the dots to specific policies, see what's working.
Exactly. It's like putting their land management choices under a microscope, seeing what happens. And don't forget about all the other research they're doing. They're combining the landscape data with stuff like, I don't know, bird populations, insect diversity, even how people feel about these landscapes.
It's like they're building this massive puzzle, and each of those studies is a different piece. You put them all together, you get this complete picture, right? How everything is connected.
You got it. It's about understanding those connections. That's something that individual studies, they could never do that alone. It's the bigger picture thing.
It makes you wonder what they'll find as they get more data, connect more dots. Are other countries doing stuff like this? Could we have like a global network of these programs sharing data? Imagine that.
Wouldn't that be something? And, the researchers behind this paper, they're actually pushing for that. They see how valuable this kind of long-term monitoring is for any country because, well, a healthy planet starts with understanding the land itself.
Can't manage what you don't measure, as they say.
Exactly. And this program, it's all about taking those measurements, but doing it over and over. That's how we'll understand how our landscapes are changing and what we need to do to keep them healthy.
It's a good reminder that those small, gradual changes, they matter too. It all adds up in the end. But let's get back to those surprising findings. You mentioned it was hard to map certain things.
It's true. Common things can be surprisingly tricky to track. You'd think the more of something there is, the easier, right? But not always.
Yeah, seems counterintuitive. Why is it so hard to get a handle on the common stuff?
Well, take grasslands, for example. Sounds easy to map, right? It's just grass. But there are actually tons of different types of grasslands, each one with its own personality, its own species. And those subtle variations, really tough to see from above.
Like trying to tell flour apart from a distance. They're all white and powdery, but they're not the same. Important if you're baking right.
Exactly. And just like a baker needs to know their flour, ecologists, land managers, they need to know the nuances of those grasslands to make good decisions.
So how do they do it then? How do you make sure you're getting those common but subtle differences right?
That's where the field teams come in. Remember them. It's not enough to just look from the sky. Sometimes you got to get down there, get your hands dirty.
A ground truth mission for all that aerial data.
Right. They go to the places that look a bit iffy in the photos and gather more data. Soil samples, plant IDs, tree counts. It all helps to paint a clearer picture.
Seems pretty meticulous.
Yeah.
But I guess with landscapes, you can't take shortcuts, right?
You got it. And that leads to another interesting point from the paper, the importance of accepting uncertainty.
Uncertainty. What do you mean?
Well, in science, there's always going to be some uncertainty. You can't measure everything perfectly. There are always going to be gaps in our knowledge, The important thing is to acknowledge those limits.
So be honest about what you know and don't know.
Exactly. And the authors of this paper, they do that really well. They're upfront about the limitations of their methods. Their data's not perfect, and they admit that.
Which is refreshing, honestly. We often think of science as this quest for absolute truth. But really, it's about getting comfortable with the unknown and constantly trying to get a little closer to the truth, right?
Couldn't have said it better myself. And that's what makes this landscape monitoring so cool. It's not about knowing everything. It's about asking good questions and developing the tools we need to keep learning as our landscapes change.
And speaking of adapting, has the program itself changed over time?
Excellent question. It shows how dynamic this type of research really is. They're not just sticking to the original plan no matter what. They're constantly learning, refining, adapting to new information.
I love that. The behind the scenes of science is fascinating. What are some of the lessons they've learned so far?
Well, one of the big ones has been the importance of flexibility. Remember the 4 areas they're monitoring: structure, biodiversity, and all that.
Yeah, I'm practically an expert now.
Well, it turns out that measuring those things, it's not always simple. What they're finding is those specific indicators they're using. Sometimes they need to be reevaluated, maybe even replaced as new information comes up.
So it's not set it and forget it. It's more like always be ready to adjust course.
Exactly. Science is about asking questions, testing, being open to changing your mind when the evidence says so.
It's like they're on this journey of discovery, and the landscape is their guide. So where does this journey lead? We've talked about the how of this monitoring. What about the why?
That's what we'll explore in the final part of our deep dive. Stay tuned as we uncover the big picture implications of Norway's journey to understand their changing landscapes.
All right, back for the grand finale. We've been exploring Norway's landscape monitoring program. It's like they've got a crystal ball, but for farmland.
Minus the vague pronouncements and hopefully more accuracy.
Definitely. So big picture time.
Yeah.
What are they hoping to achieve with all this? Knowing how the landscape is changing down to the tiniest detail. What's the point?
The goal is to figure out how to best manage that landscape going forward, which means balancing a lot of different needs.
Different needs, like what? Give me the rundown.
Well, we need farmland, right, to grow food. But we also want biodiversity. You got to protect those cultural and historical spots. And people should be able to enjoy these spaces, too. It's a lot to juggle.
An understatement. Like a giant game of Tetris, but with real-world stakes.
And just like Tetris, you got to know where the pieces fit best. That's where monitoring comes in.
Okay, so give me an example. How does this actually play out?
Remember those hedgerows we talked about? Good for wildlife, but disappearing.
Yep, those vanishing hedges.
By tracking how many there are over time, and then layering on that info about birds, insects, even things like pesticide use, they start to see the connections.
So they can tell if losing hedgerows means fewer birds, for example.
Yeah.
Or figure out farming methods that don't require ripping them all out.
Exactly. Knowledge is power, right? They're not just guessing, they're making data-driven decisions about the land.
So much better than flying blind.
Yeah.
But we talked about the challenges, the uncertainty, the constant need to adapt. What about the wins? Anything they've learned that they weren't expecting?
One of the coolest things has been the value of looking for what's missing.
What's missing? Okay, now you have to explain that one.
Seems weird, right? You'd think monitoring is about what's there. But sometimes the absences are just as important.
All right, I'm hooked. Example time.
They've been tracking abandoned buildings on farmland. At first, you might think, Who cares? Old barn, whatever.
But there's more to it.
Way more. Those old buildings, leftovers from older ways of farming, they can be havens for wildlife.
Like owls nesting in the hayloft.
Exactly. So by tracking these disappearing buildings, they're not just seeing a physical change, they're seeing potential habitat loss too. Something they wouldn't know if they weren't looking for those absences.
That's wild. The missing piece is telling a story. But we've got to wrap up soon. What's the takeaway for our listeners, even if we don't have satellite cameras and teams of scientists?
It boils down to something we all can do. Pay attention. You don't need a PhD to be a landscape detective.
We can be citizen scientists right in our own backyards.
Exactly. Next time you're out and about, really look at the landscape. What's changed over time? More houses, fewer trees, different crops.
It seems small, but it all adds up. Helps us understand the places we live in and how they're changing.
And that understanding, that's where protecting those places starts. Can't protect what you don't notice.
Too true. So listeners, challenge time. Put on your observation hats, get out there, and see your landscape with fresh eyes.
You never know what you might find. Could change how you see those everyday places forever.
And on that note, we'll leave you with one last thought. If you could design a landscape monitoring program, what would you track? What changes matter most to you, and how would you measure them?
Hit us up on social media. Let us know. Use the episode hashtag.
As always, thanks for joining our deep dive. Until next time, keep those observations sharp.